Alright, in this video we're going to finish up page 12 of Notes 2. And basically what we're doing is we're writing Taylor polynomials, which you could easily extend into Taylor series. We're writing Taylor polynomials for two different functions that are kind of famous limits. So that's why we're doing this. So let's get started. So the first function is f of x is 1 minus cosine of x over x, where x is not equal to 0. So the reason that x can't be 0 is it's undefined at 0. But a question might be, what's the limit as x approaches 0? And obviously you could just use L'Hopital's rule. Depending on how you learned calculus to begin with, or limits to begin with, you might have just memorized the limit of this function as x approaches 0. But we're going to look at it using Taylor polynomials and show that it's kind of an easy way to do it. So first thing we're going to do, focus in on that cosine of x and write down the series for that. So this you should have memorized. Cosine is an even function, so it only has the even powers. And remember, 1 is really 1 times x to the 0. 0 is an even number, so it follows the pattern. So we have this. So that you should have memorized, hopefully. If you don't have that memorized, life is going to be really hard when you're taking Calc 2. So we have this. Now what I'm going to do is I'm going to rewrite, well, not rewrite, I'm going to do 1 minus cosine. So 1 minus cosine of x on this side is the same as 1 minus the whole thing that I wrote last time. So just kind of repeating that. So even powers. The more often you write it, the better off you are. I mean, it's kind of boring to watch me write it, but I assume you're kind of writing along. I don't know. So we have this. Okay, so the way that this works is on the right-hand side, I have 1 minus 1, which is 0, and then all of the signs are just going to change, right? Because I'm really distributing a negative through there. So 1 minus cosine of x has as its Taylor polynomial just x squared over 2 factorial, and then minus x to the 4th over 4 factorial, plus x to the 6th over 6 factorial. So all the signs have changed. This, the way I'm dealing with the nth term is all the signs changed, so I just changed it. You could leave it as plus and then kind of distribute the negative 1 and get negative 1 to the n plus 1. That's totally up to you. It doesn't really matter. Now what I'm going to do is go through and divide everything I see by x. So on the left-hand side, you get 1 minus cosine of x over x, which is what I was hoping to get. That's f of x. And then on the right-hand side, it just decreases the power of x by 1 in each term. So we get this. And the nth term ends up with 2n minus 1, because that's what happens when you're dividing. So we get that. Okay, so having done that, what I can do is I can actually now evaluate this limit. Limit as x approaches 0 of 1 minus cosine of x over x is going to be exactly the same as the limit of the right-hand side of that thing that we wrote. And it's easy. You can see the pattern, right? We could extend that out to infinity, which would turn this from a polynomial into a power series. Power series are just infinitely long polynomials. So we have this. And if you look at the right-hand side there, every single thing has an x in it. And since every single thing has an x in it, when I let x equal 0, I end up with the value of the limit being 0. So here we go. Limit as x approaches 0, 1 minus cosine of x over x is just 0 because everything still had an x in it. Which is one of the really nice applications of Taylor polynomials, Taylor series, as you're first learning them, is that you can use them to evaluate limits that would otherwise require L'Hopital's rule. There are actually some limits that you could use L'Hopital's rule on that take 15 iterations maybe, and if you use a Taylor polynomial / series approach, the answer just drops out immediately. So here we have sine of x over x. Do the same thing we did. So I'm going to write down sine. Sine is odd, so you only get odd powers. So I'm going to start with x and then alternate cubed over 3 factorial, plus 5th over 5 factorial, minus 7 over 7 factorial, and then we have our kind of general term. Okay, and now what I want to do is take everything and divide through by x. So sine of x over x, which should be just decrease the power by 1. So what's interesting is now you see on the right-hand side there's a 1, and then everything still has an x with it. So when we use this to take the limit as x approaches 0, that 1 is going to stay and everything else disappears, which tells us that we can take this limit as x approaches 0, sine of x over x, is the same as the limit of the right-hand side up there, just taking the limit of both of them. So we have this, and if you look, there's only there's a 1 and then there's x in everything else. So when I take this limit, the only thing left is going to be 1. So I have figured out this limit, which is kind of a tough limit when you first run into it, actually. I mean, when you learn L'Hopital's rule, very easy. You learn Taylor polynomials, Taylor series, very easy. Before that, you need like geometry to kind of work some things out, and you probably just looked at a graph of it and were like, yeah, that's definitely 1, and kind of moved on. But anyway, this is a really nice, kind of simple approach to it. Hope you found this helpful, and good luck.